Hello, and welcome back to Encodex Education. It's great to have you here again for our Essentials Linux, Git, and Docker for Data Engineer series. In the previous lesson, Core Commands, File System Navigation, Permissions, and Process Management, we explored how to move around, inspect, and manage resources inside a Linux system. Today, we are diving into Linux basics, shell scripting, simple automation with Bash, loops, and conditionals. By the end of this session, you'll understand not just how to write basic shell script, but also why Bash was created, how it works under the hood, and how companies use it for data engineering workflows. Let's get started. Before we jump into writing scripts, I want to explain what a shell is and how Bash came to be. A shell is essentially a command line interface that interprets the commands you type into your terminal and interacts with the underlying operating system. Bash stands for Born Again Shell, originally developed as a free software replacement for the Bourne Shell (SH), which was one of the earliest Unix shells. Bash incorporates many features from other shells such as Cheese Shell (CSH) and the Corn Shell (KSH). Bash works by continuously reading the commands you type in or the lines of code in a script, interpreting them and passing them to the kernel to execute. Its design is flexible enough to allow powerful scripting capabilities. From a data engineering standpoint, major organizations use Bash scripts to automate routine tasks like spinning up servers, cleaning up log files, orchestrating data, transfer jobs, and more. Those scripts can be scheduled with cron or integrated into larger pipelines that tie together big data components. Understanding Bash is a fundamental step in mastering the automation aspect of data engineering, because at some point, everything in a Linux-based environment can be manipulated or triggered through a shell command. If you want to follow along, open up a terminal on any Linux distribution or in a container environment where you can run Bash. If you're on macOS, you likely have ZSH or Bash installed by default. For Windows, using WASL, Windows Subsystem for Linux, or a virtual machine works just fine. Let's start by making a dedicated folder for our practice scripts, so we can stay organized in your terminal. Navigate to your home directory or wherever you like to keep your projects, then create a new folder. Let's do mkdir shell scripting demo. Perfect. Let's go to it. cd change directory shell scripting demo. Perfect. Let's use pwd. Okay, we are in the right folder. Now, let's create our first script by doing nano hello world.sh. Perfect. This opens a text editor where we can write our code. Now, first of all, the shebang. The shebang indicates which interpreter should run this script. So we will do user bin env bash. User bin env bash tells your system to look for the bash interpreter in your environment's path, making this script portable. Now, we start our actual commands. The echo command prints text to the screen, so we will do echo hello world from Encodex Education. Perfect. Now, we do Ctrl X, Y, and Enter, and we save our file. When you are done, save and exit the editor. Before running the script, let's make it executable by doing chmod plus x hello world.sh. Now, we should see on WASL, for example, our code is green. The name of the file is green. So Now we can run it directly by doing dot slash hello world.sh. Perfect. You should see the message hello world from Encodex Education printed to the screen. Congratulations, you just created your first bash script. You might be wondering why that initial line, the shebang, is so important. The line tells your operating system which interpreter to use. Instead of having to specify bash hello world.sh every time, your system now knows automatically that whenever it sees this file executed, it should use bash. Shell scripts allows us to store values in variables. Variables are useful for dynamically referencing specific data within your scripts. Let's create another file to explore variables. Let's do nano variables.sh. Let's first of all indicate that our interpreter is bash by using the shebang. So we will do user bin and bash. Perfect. Now, let's declare a variable named greeting and assign a string value by doing greeting welcome to Encodex Education. Perfect. Now let's declare another variable for username by doing username equals data engineer 101. Now let's print out the values stored in the variables by doing echo. We use the dollar sign to reference the variables. So we do dollar sign greeting and dollar sign username. Perfect. Now, we'll store today's date in a variable using command substitution by doing today date equals dollar sign open brackets date, and we do echo today is, and we reference the variable today's date. Perfect. Now let's save it, exit, and make it executable. We will do chmod plus x variables.sh. And now let's run it. /variables.sh. Perfect. Your terminal will display messages showing your greeting, username, and today's date. Loops are critical in data engineering tasks because they let you repeat operations on multiple files, directories, or servers. Let's build a script that demonstrates how to loop over a list of items. Let's do nano loops.sh. Then let's put our shebang user /bin /env, and we put bash. Perfect. Now, this script demonstrates a basic for loop in bash to iterate over a list of elements. So let's first of all, we define a list of file names. In a real scenario, these could be data files. So we'll do file names. We open the brackets to define an array, and we do file1.csv. Don't put this, okay. File2.csv and file3.csv. Then you close the brackets. Look well at your code so that you don't make syntax errors. For loop to iterate over each file name. To do it, we do for file in, and we reference the array file. We need to open the brackets first. So file names. We open squared brackets and we put the at. Then we close, and this is how you reference an array on bash. Then we do. Let's print a message to show which file we're on. Echo processing file. Then let's simulate some processing like copying or compressing the file. Here we're just echoing a message to simulate a real operation. So we do echo finished processing file. Perfect. And then we do echo and we add some spacing so that it will iterate on multiple elements. Then we do done. And this is the end of the loop. We save. We do chmod plus x loops.sh to make it executable. And then let's execute it by doing ./loops.sh. Perfect. As you can see, it looped in the array and echoed for every element in our list the echoes we have inserted on the bash code. In the script above, we have a bash array named filenames. Arrays in bash are simply lists of strings, indexed by number starting from 0. By referencing the array with $, opening bracket, file names, and open square brackets at, we're telling bash to loop through each item in that array. This fundamental feature is used to extensively in data pipelines for iterating over large sets of data files. Conditionals lets you make decisions in your script based on certain conditions, like if a file exists or if a command succeeded. This is often used in data engineering to validate data integrity or check if the correct environment variables are set before running bigger jobs. Let's write another script. Let's clear. Perfect. Let's do nano conditionals.sh. Let's put our shebang to tell what interpreter to use to our environment, bin, and bash. Now, this script will demonstrate how we use conditionals and if statements in bash. Let's define a variable to hold a file name by doing filename equals my data.csv. Let's check if the file exists in the current directory by doing if open square brackets -f. Let's reference the file name. We close the brackets. Then, if the file exists, let's print a success message. Echo. Great news. File name exists in this directory. Else, if the file name does not exist, print a different message. Let's do echo file name does not exist in this directory. Let's create a placeholder. Perfect. Now here we'll create an empty file to simulate a real scenario by doing touch file name. And then we will do echo file name has been created. Let's close the if statement by doing fe. Then we will do another condition to check if a directory named data exists. So we do the same thing if. To check if it's a file, we do -f. And to check if it's a directory, we do -d. If dash d data, and we close the brackets. Be attentive to the spaces between. It's really important to not have syntax errors. If, open brackets, data, then let's echo. To add the space here, I just press tab. Echo directory data already exists. Else, if it doesn't exist, we do echo directory data does not exist. Let's create a new one. Okay. Perfect. Now we do make dir data. And we close the if statement again. We echo script completed. And we save, and let's make it executable. We do chmod plus x conditionals.sh, and then we do /conditionals.sh. Perfect. So it did check that we didn't have the file, it created it, it did check that we didn't have the directory, and it created it. Now let's check if our directory has been created. And the file. Perfect. My data.csv and data folder has been created. In enterprise environments, teams might rely on shell scripts to do pre-processing checks. For example, before ingesting logs into a data lake, a script might verify that a certain file is present, that it's not empty, and that it has the correct format. If any checks fail, the script triggers an alert or automatically attempts to fix the issue, like compressing old logs, rotating them out, or fetching new data from a remote source. Those kind of automations greatly reduce manual intervention, freeing data engineers to focus on complex problem solving rather than repetitive tasks. Let's create one more script that combines variables, loops, and conditionals in a brief automated flow. Suppose we want to create a set of data files only if they don't already exist. We'll also rename them if they do exist. Here is how we might do that. Let's do nano automation.sh. Then let's define our shebang by doing user bin env bash. Perfect. This script simulates a simple automation process that checks for existing files, renames them if necessary, and then creates new files. Let's define an array of file names we want to manage by doing file list equals open brackets data January.csv, data February.csv, and data Mars.csv. Perfect. Now let's loop through each file in the list by doing for file in our array file list do if open square brackets -f file then echo file already exists. Renaming to file dot old. Now we will rename the file by appending .old to the original name. Then we will do move file to file .old. Perfect. Else, so if the file doesn't exist, we will echo file does not exist, creating a new file. Now let's create an empty file. In a real scenario, you might fill it with data. Let's do touch. File. Then we close the if statement by doing phi, and then we close the for loop by doing done. Perfect. Let's add a last statement by doing echo file management automation complete. Let's do Ctrl X, Y, and enter. Now let's make it executable by doing chmod plus X automation .sh, and let's do /automation.sh. Perfect. Now if you check your directory with ls, you should see that it has created the data files. Now we will rename it again, we will run it again, and the existing files will be renamed and the new ones will appear in their place, simulating a versioning approach. Perfect. If you ever run into permission issues, remember to use chmod plus X and the name of the file to make a script executable. Also, if you receive a command not found error, verify that your shebang is correct and that bash is installed indeed. When dealing with variables or loops, make sure you enclose strings with spaces or special characters in quotes to avoid unexpected word splitting. We've covered a lot of ground. How bash is structured, why it was created, how major companies use it for automation, and the fundamental code constructs like variables, loops, and conditionals. By combining those concepts, you can create powerful automation routines that help streamline data engineering tasks. Thank you for joining me for this deep dive on Linux basics, shell scripting, simple automation with bash, loops, and conditionals. In the next lesson, version control fundamentals, initializing repos, staging, committing, and branching, we look at how to track changes to those scripts and all sorts of code. Using Git, ensuring we don't lose work and can collaborate effectively. If you find this helpful, give the video a like, subscribe to Encodex Education, and I'll see you in the next one. Until then, happy coding!